Hello, everybody. Thank you for everyone who joined today. My name is Nicholas Campa. I am a pre-sales engineer and solution architect with Login BSI, and I'm very excited to discuss some tips and tricks of how to set yourself up for success when you're developing and implementing a test environment. Just for timing reasons, so we can stay on track there, please leave any questions you might have in the chat so that I can circle back at the end during the Q&A time. But without further ado, let's jump right into the agenda of what we'll be covering today. After a quick introduction, we'll jump right into the importance of test environments and the crucial role that they play. After that, I'll share some of my experience in developing a test environment. I think that'll be a good intro and tie into the next topic, which is some high-level considerations that you should make during your planning and design phases. And lastly, after some key takeaways, we'll wrap up with that Q&A. So a little bit about myself. I did my undergraduate at Loyola University in Baltimore, Maryland, and I studied data science and business administration. This is really where I gained my passion for using technology to solve business problems. I knew that there was a big need in the market for understanding data and how to leverage it to solve problems, and really fit perfectly with my interest in understanding more about what makes businesses successful. My undergraduate also coincided with the large-scale adoption of cloud technologies during COVID, and I really quickly realized that I wanted to be a part of this rapid, innovative space. And that being said, I really wasn't sure what angle I wanted to take until I was introduced to Login VSI. And when I first joined and began to really understand and learn about the technology and how it worked, I almost instantly recognized the value of the actionable data that was collected. I'm always reminded of the 80-20 principle, and I have here that 80% of businesses want to use data to drive their decision making, but only 20% actually do. But by using Login Enterprise, IT administrators can effectively simulate any situation that they're going to encounter and be confident in the systems that they're delivering. It provides them with a data-driven approach to change management and user experience, and ultimately just deploying virtualized desktop environments. I didn't have much experience in the EUC space or with EUC technologies until recently, but I've always enjoyed learning new stuff and taking on a challenge, so it fit right in with my interest there. As a pre-sales engineer, I spend a lot of my time having conversations with customers and prospects, learning about their unique technology stacks and some of their unique challenges. I lead a lot of product demonstrations and proof of concept implementations, as well as managing our newly developed testing environment that I actually developed and will share with you in a little bit. But first, we'll start by discussing why a test environment is so important and the crucial role it plays, as well as some of the challenges that are presented when you are trying to build and develop one. So test environments should ideally be the last gateway before production. And this also means that this environment is the last place to observe the quality of your service, as well as catch any code defects that might impact availability or end user experience. You can imagine an organization that doesn't have any testing strategy or test environment. Without the ability to validate any changes that they're going to introduce to their real end users, the business ultimately relies on those real end users to notify them of any performance or availability issues in their production environment. While this is generally not good practice whatsoever, there are certain situations where this can be particularly dangerous, including healthcare, where poor testing can actually lead to doctors and clinicians that are unable to provide the best care for patients. And in those cases, it actually can become a life or death. That being said, how you design your testing environment will ultimately dictate the value that's added by using synthetic user testing. Because from a design perspective, the scale is not as important as the configuration, but a test environment that doesn't align with your production configuration is going to generate inaccurate data that's not really representative of what's going to happen once your infrastructure is actually rolled out to your real users. And there are some nuances here depending on the use case that we'll actually cover later. But if you didn't already, hopefully you recognize the need for an effective testing environment and the role that they play. You might be asking why every organization doesn't just have and build their own testing environment, and that's because there's some challenges in developing them. With dense technology stacks that are continuing to add layers and increase in complexity, the need for thoughtful planning and design becomes even greater. You can see here in this little diagram that I've added here, there's so many components to consider, from type of environment, your hypervisor, your operating system, up to some configuration policies, including security and maybe some group policy objects, and ultimately the numerous applications that your system might provide to your end users. And with all this to consider, it might be a little daunting in deciding where to start. But with all of that said, attempting to recreate your production stack might raise some cost concerns. It might seem impossible to implement a test environment that mirrors your production environment without the same price tag. And this is especially true in the cloud, where we see resources that can accrue high costs without ever even using them. And leading up to this presentation, I did a little homework and read countless articles and blogs talking about the whys and hows of testing environments, and they basically all described similar concepts of why they're so important and some of the common issues that arise without proper testing. But if there was one thing common between them all, it was the assertion that there really is no such thing as a perfect testing environment. Usually due to cost or design limitations, perfect test environments aren't even feasible. While having a testing environment that perfectly mirrors production is the only way to ensure the perfect accuracy of your data that you're collecting, those perfect ones are very rare and nearly impossible to actually build. My colleague likens a technology stack to an organization's DNA, and that's because it's usually unique to them. No other organization has all of your unique settings, whether it's, again, down to your hypervisor, your OS, up to your policies and your applications. And that also means that there's no one-size-fits-all approach to building a test environment that addresses all of those unique needs. And that being said, this means the responsibility most falls on the architects and developers who are responsible for building them to understand some of the unique requirements and how to address them. And that's basically why we're here today. So just switching up speeds a little bit, I'd like to share now with you some of my experience in designing and deploying a test environment for our internal use and some of the decisions we made while building it. It might be taking a little bit of a different perspective than some of you might have as you look to develop test environments for your own businesses and IT organizations, but I think there's definitely some overlapping concepts that can definitely be applied. So like I mentioned, this experience, along with some articles and blogs, was really the foundation of what I'm going to be covering today. Just to set the stage, our pre-sales team needed an environment to better demonstrate our use cases as well as perform some sandbox testing. And we wanted it to be emulative of what we were seeing in the field. And to do that, we deployed a small-scale Citrix site using Terraform to define and provision the underlying storage, networking, security, and compute resources, and ultimately PowerShell to configure each server according to their respective roles. One of the most important design decisions that we made was to keep it simple by only including 2 tools in our stack, 3 including Azure as the cloud support. We reduced the barrier to entry for those engineers who want to further customize the deployments. Because we chose Terraform, it meant that addressing scalability was straightforward and most of the code that we actually wrote was reusable. It's still in its early stages at this point, but we are planning on creating templates to deploy for each unique testing case. And for example, we could deploy a multi-server Citrix site for more realistic load scale testing. And because we can use our initial code as the foundation for that, most of the heavy lifting is already done. Another key to this project's success was the agile project management that we borrowed. But we used a Kanban board, and this allowed us to keep on track by highlighting work that was in progress as well as work that needed to still be done. And creating artifacts along the way made it easier to stay in line with our original planning and design, as well as using any referencing architectures or code snippets that we would need down the road as well. And the big thing here also is that using Kanban and agile management meant that we weren't trying to do everything at once. So by focusing on building it up from the foundation and validating each dependency along the way, we made sure that we weren't doing any work that was going to cause unnecessary complexity when we went to go troubleshoot what we had just been building. So here is just a basic diagram of the architecture that we ended up deploying. So as far as the Citrix site goes, it basically just included the minimum requirements to launch user sessions. So we had one SQL server as the site database, one delivery controller, one storefront server, and one VDA server. And again, here, I think a key is the simplicity in the design that we took. So if you look here at the diagram, you can see every server, every Windows server at least, basically had the same few components and steps that needed to be done. So after assigning a public IP address and attaching a network card, we could basically, create the virtual machine, join the domain, and enable WinRM. And those are all steps that need to be done for all of these 7 virtual machines right here. So basically, this meant that we could pretty much copy and paste the code with some few minor tweaks across the servers and accomplish a much easier troubleshooting and testing during the initial development. The persistent storage on the bottom there is actually not a part of our initial design, but rather the result of a change in strategy because of a problem that was actually identified as we were going through the development. As we were aiming for a fully automated service, we tried to initially start by using Terraform to create the storage accounts on the fly. And this ultimately resulted in some timing issues as we were deploying some of the supporting infrastructure. And when some of these machines would go to request data from the storage account, it wasn't actually initialized or ready to be accessed, basically. And because of this, we realized that a persistent storage account was the better option. And also, between even Azure regions, the network speed was really vastly different and unpredictable. And because of that, it really wasn't a long-term solution. And another interesting component here is the task launcher that you see there. And the launcher machine is actually one of the software components required for a login enterprise deployment. It's used to launch the user sessions into your digital workspace. But because there were minimal requirements during the initial deployment where, these other servers hosting Citrix sites really had a lot more requisites. So we used that to run some data file transfers in the background in parallel. And this also let us identify that copying files from our local machines into Azure was almost 10 times slower than actually using the persistent storage account and transferring it between 2 Azure resources. And this change in our design actually sped up and decreased our deployment time by almost a half hour. So ultimately, this was definitely a more viable solution. Ultimately, the project was a success, but if I could do it over again from the start, there would definitely be a few areas that I would manage a little bit better. And it all starts with some considerations that could have been made during the planning and design phases at the beginning. So let's discuss a few of them here. And let's start with the planning phase. As with any complex project, the initial planning that you do ultimately is going to set the stage and direction for going forward. You can start by bulletproof planning for all contingencies, and that can help you reduce the chance of any delays in progress. Like I mentioned before, consider using a Kanban board to keep track of what needs to be done, what's being worked on, and what has already been completed. This allows for better collaboration, but also visibility into the ongoing progress that's happening. During the planning, as I mentioned, you can create artifacts to document any potential issues that can happen and your plans to overcome them as well. That being said, it's sometimes hard to identify a potential issue until it actually happens. I like to think of the old saying, the devil you know is better than the devil you don't hear, because if you can identify potential roadblocks that can delay you ahead of time and have a plan B for them, it actually lets you spend more time on those more difficult and unpredictable issues that might arise that ultimately are going to require more heavier lifting to work around. And that's also why it's important to build a framework that is adaptive and can adapt to changing requirements. Whether it's a change in design because of an issue that arose, like I mentioned, or maybe it's a different scenario and a stakeholder made a request that's going to necessitate a change. You don't want to back yourself into a corner based on how you plan to design your environment. This can delay testing schedules and ultimately leave your production environment vulnerable to performance and availability issues. So to prevent delays in development, you can also consider which siloed teams might be required. Maybe it's an Active Directory team, a database team, maybe it's an asset team to create some testing accounts or dummy data, or to get some third-party software licensing. And this is just an easy way to avoid delays down the road that can postpone crucial testing. And lastly, I have here just aiming for simple management and maintenance down the road. It's important to keep in mind who's actually going to be owning the environment once you build it. And you want to be able to design an environment that's ultimately easy for them to manage and maintain. And there's a few steps during the design, and as well as some different automation tools that can be used to simplify that as well, that we'll cover in the next few slides. So once you've finished your initial planning, it's time to sit down and design the actual architecture of your environment, and using the planning as your initial alignment with your core requirements, and they should act as guide rails for your design. So when you're determining what components might be required for your environment, lean on your reference architecture. Consider your service, your unique service, and outline any components that are integral in your chain of delivery. Also identify any components that might be out of scope for what you're trying to test. During the design phase, it's also important to consider what type of testing is going to be done in your environment. Ask yourself what you're actually trying to observe. The test case here and the desired outcomes often dictate some of the design requirements. And most importantly, it goes back to hand in hand with planning for changing requirements. You want to design a dynamic deployment method. It could also have, besides adapting to changing requirements, it also has benefits while you're developing. For example, as I was building and testing out my environment, deploying the whole kit to validate a small portion of it, like a server's domain membership, it really wastes a lot of time and effort. And you could also simplify your deployment by using a building block approach and focus on validating the dependencies before you find yourself going down a rabbit hole trying to diagnose why a specific process isn't working as a result of a failed dependency, for example. And once you understand the design requirements, creating configuration templates prevents over provisioning or under provisioning your environments. Different test cases have ultimately different requirements, and using templates to address those needs is more efficient than manually changing the code and introducing some bugs. You can start with an outline of the infrastructure that meets your high-level requirements, and by using a tool like Terraform, it makes it pretty easy to quickly change variables and customize your kit to address those changing requirements for each test case. So to get a little bit deeper into some of the value that's added by creating infrastructure templates for each test case, comparing two common test case examples is probably a good place to start. So I've included here system integration testing, which might be among the first times you're bringing together all of your infrastructure, including your agents, your applications, and all of their intertwined dependencies. For functional test cases like SIT, consider using the minimum required hardware specs. If a process functions on the minimum requirements, you can be confident that it's going to function on a more powerful machine in production. Comparing that with user acceptance testing, which is usually among the last steps before you're going to deploy an environment into production, the aim here is to ensure that your system is going to provide an acceptable end user experience. Because most of the functionality concerns have been addressed in earlier testing stages, you want to replace your minimum spec servers and test against a system that matches more closely your production configuration. So if you started with a vanilla infrastructure template, like I mentioned last slide, you can start to make some customizations based on each use case. An environment for SIT testing might use the minimum required hardware or cloud instances for any servers hosting authentication services, databases, or desktops and applications. Again, because the main concern is functionality, you can get away with saving some money here. As I mentioned, the configuration is much more important than the scale. But as you move into user acceptance testing, the concerns shift away from functionality and towards acceptable end user experience and performance. In this case, there's definitely less room for error, and you want to validate your system against the same infrastructure and configuration as your real users would, but at a smaller scale. And in these cases, using different hardware or cloud instances can result in that inaccurate data that I was mentioning, and can result in rolling out an upgrade that's unstable to your end users. So as you go through the different stages of testing and inch closer to production, you want to make sure that your testing environments are also getting closer to mirroring more closely your production environment. Again, here, the key is the scale of your environment is not as important as the configuration. It's much easier and straightforward to extrapolate capacity when compared to understanding performance impacts of profile management solutions or different security agents. So 3 easy ways to address cost concerns here, and managing cost concerns in a testing environment is among one of the most important aspects of managing an environment like this. But just to start, number one, in creating templates on a test case basis, you can be pretty granular in applying your design and also save on those incremental costs for components that are not universally required. Consider the example of system integration versus user acceptance testing. As you further validate your deployment, you'll want to further emulate your production configuration. Using templates is an easy way to preemptively eliminate unnecessary costs and manual code changes that introduce bugs to your code. And you kind of want to avoid testing bug fixes in your test environment, as that sort of presents sort of an inception situation. But the second point here is to avoid fully persistent deployments. While some components, such as storage, as in my environment, might require persistency, using the power of automation to rapidly scaffold your environments is just an easy way to cut down costs. Most testing is not done out of the blue, which means that your users and testers are going to know in advance what they're trying to test for and when they need it. So ideally, you can aim for as few persistent components as possible there. And lastly, the third point is to, wherever possible, take some liberties. As I mentioned earlier, not every test case requires the full deployment or has the same requirements. Carefully consider the test cases where you can get away with not using identical hardware specs. Using templates makes this decision process simpler because you only have to make it once. You can also determine which components, if any, are out of scope for your test cases and eliminate them altogether. So now that we've outlined a set of high-level requirements, you want to aim for a fully automated deployment. Not only is this going to rapidly speed up the deployment process, it's also going to remove any time-consuming manual processes that are associated with it. During development, first automate the tasks that are the simplest to automate. Remember, not every step needs to be automated, but eliminating the error-prone tasks is one way to foolproof your deployment. Ideally, the less hands that touch the environment while it's being built, the better. Automating your build can also allow you to develop the templates I've been mentioning. As I've already been saying, creating templates for each test case allows you to deploy a specified infrastructure that meets your unique testing needs and include or exclude any specific components altogether. There are numerous solutions to address automation, many of which are, at the end of the day, going to provide the same capabilities to your team. Consider what your team is already skilled in or has experience with. Think about tools that are already being used in your stack. So here, there's really no need to reinvent the wheel. And by using past experience and already existing skill sets, you can really just streamline your entire process here. Terraform, I've been mentioning, is a major player in the infrastructure as code space. And some of you might have used Terraform or do use Terraform. And the same goes for Ansible and Chef, which are two popular options for cloud resource configuration. And a pairing of these two tools really allows you the flexibility and control that's required to make the necessary changes and requirements fit. And lastly here, tie it all together using a pipeline tool like Jenkins or Azure DevOps. This will allow you to continuously deploy any code changes, and it's also another way to improve the reliability of your environment. Using a pipeline tool can integrate your team's latest and greatest optimizations and ensure you're always testing against the most recent builds. Lastly, before I wrap up here, I just want to highlight some key takeaways. If you forget everything else, just remember these concepts as you start to begin developing your own environments. So first and foremost, remember that the opportunity costs are high, but the cost of not developing a test environment is higher than the cost of supporting it. Any outages in poor performance can directly translate into decreased productivity, sometimes lost revenue, and in some cases, as we mentioned in healthcare, it can result in life or death situations. Also remember, there's no perfect test environments. Every organization has a unique tech stack, and that means every organization's test environment should look a little bit different. Similarly, there's no one-size-fits-all approach. This goes hand in hand with the no perfect test environment point, but designing a deployment that meets your unique testing needs and staying flexible to adapt to any roadblocks or changing requirements is a critical factor as you are going through your development process of your test environment. And that's why it's important to carefully plan and design your environment. When we kicked off our planning of our testing environment that I mentioned earlier, we really knew what we wanted to do and accomplish, but we weren't really sure how we were going to get there. So you want to consider your test cases and your desired outcomes and plan accordingly as you go through these earlier phases. I mentioned it a few times, but it's really critical that you want to aim for a fully automated deployment. With that being said, you don't want to waste time automating every single task. Focus on the tasks that are error-prone or might be laborious to complete. Remove as many hands from the deployment as possible. And lastly, using a centralized project management tool like Kanban to streamline collaboration. Try to leave notes for yourself when you drop the project for other responsibilities, and this can make it easier to pick it up where you left off and hit the ground running. So with that, any questions that might be asked, I'm going to check the chat right now. Otherwise, you can reach me at my LinkedIn, Nicholas Campa, or my email, which is listed there. I don't seem to have any questions. So just want to say thank you very much for joining me today. I hope that you found it interesting and hopefully learned a thing or two to take away as you go to develop your test environment. And I do want to mention that after this session, we have one last session with Greg Brown. He's going to be discussing how to plan and navigate working in the post-pandemic world. So check that out for some interesting insights there. But otherwise, again, thank you for joining me today, and I appreciate your time. Thanks.